The partial sum theorem. Suppose we have a series whose terms a sub n are positive for all n. We can represent this on the graph. Each of the terms has a width of 1 and height a sub I. All of these are above the x-axis. The partial sum of the series is the sum of the first n terms. S sub n is a sub 1 plus a sub 2 all the way to a sub n. S sub n plus 1 is a sub 1 plus a sub 2 all the way to a sub n and a sub n plus 1. Now this is S sub n plus a sub n plus 1, which is positive, and so we see that S sub n is less than S sub n plus 1 for all n. This means the sequence of the partial sum S sub n is monotonic because it is increasing. You keep adding positive number to the partial sum. The partial sum theorem for the positive series states that if we have a series whose terms are positive, this is called the positive series. The terms a sub n are positive. Then there are two possibilities. One, the partial sum S sub n are bounded above. In this case, the series converges. This is because the sequence of the partial sum is increasing and bounded above. So by the monotonic bounded theorem, the sequence converges. 2. The partial sums S sub n are not bounded above. In this case, the series diverges. If it is not bounded above, then the limit will never be finite. What this theorem implies is that if we have a sequence of the partial sums, remember that we start out with a series a sub n where a sub n terms are positive. The sequence of the partial sum S sub 1, S sub 2, S sub 3, and so on. This is an increasing sequence, therefore it is monotonic. And if we were to keep adding numbers to each of the terms each time, we start out with the partial sum S sub 1, S sub 2 is S sub 1 plus the next term, S sub 3 is S sub 2 plus the next term, and so the sequence of S sub n is increasing monotone, but if it is bounded above, then this sequence converges to a finite number, and that is the definition of the convergent series. That is, the sequence of the partial sum converges and its limit is a finite number. Remember that an infinite series converges only if the sequence of the partial sum converges.